All right, so it says find the real solutions of 4x to the fifth equals 28, and then they give us another one. So let's do the first one first. So I'm going to zoom in over here. If I say 4x to the fifth equals 128, first thing I want to do is get rid of this coefficient. So our process is still the same. We want to get x equals some stuff. We're going to do the inverse to move stuff to the other side. So I want to get the x by itself. So you kind of go like in a reverse order of operations because you're undoing what's being done. Normally we would do exponents first and then multiply, but we're undoing what's being done, so we're going to get rid of the multiplication. 4x is 4 times x, so we're going to get rid of that first by doing the opposite, which is divide by 4. Kind of. It doesn't always go that way, but most of the time it does. So 4 divided by 4 is just 1, so I get x to the fifth. Now what is 128 divided by 4? 32. Now, it's no accident they keep telling us that 2 to the fifth power equals 32. There's a reason they keep using those numbers, right? The reason they tell us that is because I'm going to have to undo the power. So if something's raised to the fifth power, then I must take the fifth root. Same thing over here. I have to take the fifth root. Well, the fifth root of 32 is just 2. Does that make sense? So that's the solution for that one. I'll slide over and do the next one. So now on the next one, these are a little trickier because it's not as cookie cutter. It's not like you got to think on your feet. So what do you think we need to do first? Well, there's a 3 and a 4 that I need to work with. Remember, I want to make this look like x equals some stuff. So I got to get the x completely by itself. Now in this case, I need to get rid of that exponent. So I'm going to take this whole thing and raise it to the fourth root. Remember, whatever I do on one side, I have to do to the other. One little thing though, when we do even roots, remember that an even root has a positive and a negative solution. So we have to tack on this little plus or minus thing. I didn't give myself enough space. Let me make it a little more legible. All right, well, this undoes this, so I'm left with x minus 3 is equal to plus or minus the fourth root of 21. Now, you only do that with even. So let's jot that down in our notes. Plus or minus for even roots. Okay. Notice I didn't write down the plus or minus here because we can have negative roots, we can have all kinds of stuff. So here we don't need to do that. So now, to get this x by itself, I need to move this 3 away. Since I'm subtracting by 3, I do the opposite, which is add 3. Whatever I do on one side of the equal sign, I have to do to the other. And I get x equals, now this is a positive 3. You could write the plus sign down, but you don't need to. Plus or minus the fourth root of 21. Now, if you read, it says round to 2 decimal places, so we got to put this in our fancy calculator. Okay. So I'm going to do this. I'm going to say 3 plus, and we got to hit the math button, right? Go down to option number 5. We want the fourth root of 21. Hit enter. I'm rounding to 2 decimal places, so it looks like it's going to be about 5.14. Now, because we're rounding, we have to use this approximation symbol. Now we got to do the minus. X equals 3 minus 4th root of 21. So here's a little trick, a calculator trick for you. If you go up here, use your arrow to highlight this thing and you hit enter again, it'll put the whole thing in there, and then you just come over here and change that to a subtraction symbol. Hit enter. So now if I round this to 2 decimal places, I look at the 5 and I go, do I keep it a 5 or round it up to a 6? I make that decision based on the number next to it. 9 is greater than 5, so I'm going to round this to 0.86. Again, we're chopping off some of those decimals, so it's not an exact value. So we have to use these squiggly signs, which means approximate. Approximate. Approximate value, okay? And that is it for today. Any questions?